Player movement is a critical part of good game design. You've probably heard people say that a game just feels good to play, but achieving that polished feel doesn't happen by accident. Developers use a host of invisible tricks to ensure the best possible experience for players. You can't get far in most games without good player movement. Literally. How the player moves and interacts with the game world can make or break your game.
1 minute later.
Creating natural and immersive player movement was quite difficult for me, and I know that a lot of people suffer from the same problem. And in this video, I want to show you how I handle it for my Pokemon game with a third-person character controller. Let's begin with a new 3D URP project. I'm using version 2022.3 for this video, and I've already imported a player character and a terrain from Unity's asset store. All the camera-related game objects are set up in the camera system game object, and all the terrain-related ones are in game world. I also have a post-processing stack which came with the asset. I also went ahead and copied all the animations we'll be using for the player in this video. If you choose to use this asset, the materials for the character might not render properly because they use the legacy shaders. So a quick fix is to go to the material and change the shader to the new URP lit shader. Then all you need to do is drag over the albedo texture into the new shader and it will render properly. The next thing you want to do is go to the package manager and download Cinemachine, which will give us a third-person camera. There is a bug in this version of Unity where it doesn't show the latest version of this package. So to fix that, just click on the plus icon, type in the package and version, and it will install the correct version. After that, install the new input system package, and we are officially done with the setup. To get input from the player, you need an input actions asset. To avoid the boilerplate, you can go to the player game object, add the player input component and click on create assets. This will automatically create an asset with the basic inputs already mapped to the keys. But this isn't just quite what we need. I'm also going to add a binding for the run and jump actions with the shift and spacebar keys. Inside the inspector, hit the generate C# class button and Unity will create a C# class which we can then reference from our other scripts. To handle inputs, create a new input controller script. Inside the input actions class, all we really need to be concerned with is the iPlayer's actions interface, which gives us access to all the input bindings we just created. Go to the input controller script and change the inheritance to scriptable object and iPlayer actions so that we can access it from other scripts without needing a game object. Hit command dot and all the methods for the interface will be generated automatically. We're going to need a few events for each of the player actions. So I'm going to create a Unity event of type vector2 for movement, one for mouse movement, and another for jumping. We also need a reference to the player input actions class, and I'm going to create a property for the direction we're currently facing. Inside the onEnable method, initialize player input actions using the null coalescent operator, and using the setCallbacks method, we can set this instance to the class. I'm going to add two methods to enable and disable controls, which will be helpful later. After ignoring the onFire method, we can use a switch statement to fire the jump event when the player presses the button with the value of true and with false when the button gets released using the input action face property. We can also fire the look event after checking if the device being used is a mouse with a helper method, and the move event with a vector2 value from the callback context. From there, we can just copy over the code from onJump into onRun, since they both have similar functionality, and create a new event for it. To make this class accessible from the editor, we need to add a create assets menu attribute at the top, passing in the file and menu names as parameters. Go back to Unity, right-click and create an asset for the input controller, which we can then use in the player controller script. Inside the player game object, add a capsule collider component to register collisions and modify the values to fit your model, along with a rigid body component with the default values. From there, we can drag the player controller script to the game object. We also need a new Cinemachine free look camera game object to follow around the player, which we do by dragging the player object inside the tracking target field. Adjust the values to fit your game view and notice how the player still doesn't do anything. To make the player move, we first need references to the rigid body, Cinemachine camera, and the input controller. From there, we can add properties for the move speed, the damping time, the position of the main camera, the input direction, and the current velocity of the player. Inside of Wake, cache a reference to the main camera and set the follow and look at targets to the player's transform. And with the onTargetObject warp method, We can make sure the camera will always track the player even if he manages to teleport. Setting the freeze rotation property of the rigid body will stop the player from tripping over herself. Enable the player inputs in start and set the input direction inside update to get the value every frame. Remember that the forward direction of the player maps to the Y component of the input, and by normalizing this value, the direction property will never overshoot. From there, we can update the player's movement in fixed update because it involves the rigid body. Inside the update movement method, we get the direction the player wants to move towards by rotating the vertical axis along the movement vector using quaternion multiplication. Then we can update the player's rotation and position if this direction is different than the previous direction, or set it to 0 if it's not. To create a smooth rotation for the player, we can use quaternion.slurp to create a transition between the current rotation and target rotation, and damping the value, which we can do by creating a helper function. Inside the damp function, we damp any value by using damper.damp in the time defined by the damping property, and we pass in delta time depending on whether it's a frame update or a physics update. To update the position, we can get the target velocity and use that to slurp from the current value and use the damp function to create a smooth transition. If the angle between the two is very large, then we simply add the damped value instead of slurp to create a faster transition, which we do by creating an overload for the damp function so that it returns a vector 3 instead of a float. From there, we can assign the new velocity to the rigid body without changing the Y component to avoid vertical movement. In the editor, assign the references and hit play. You'll see that our player is a true feminist by the way she asserts dominance. To make her friendly and less dominating, open up the animator and animation windows to create animations. Create a new blend tree and add the idle, walk, and run animations inside it. Rename the default blend parameter to something that makes more sense, like movement, and notice that each value corresponds to a specific animation. From there, we can go back to the player controller script, add a reference to the animator properties for smooth time, smooth, and the velocity, which will be used by the mathf.smoothSpeed function. You can also store a hash for the movement parameter to avoid strings using the string to hash method of the animator class. To actually animate the player, we can call the update animator method in update, which updates the value of the movement parameter using the smooth property. Damp the smooth property to 0 when the velocity is 0 by creating a helper method. This method calls the mathf.smoothDamp method to modify its values. Also update smooth when the position is being updated. Remember that point 5 corresponds to the walk animation. Hit play and you'll see that our player has gained the ability to walk like a normal person. To give her the ability to run, add properties for run speed and running. Register the run event of the input controller in onEnable and unregister in onDisable by calling the updateRun method, which updates the running property based on the user input. In update position, we can change the target velocity based on this property and the smooth value using the math.remap method, which basically changes values from one range to another. So if the input is move speed, 0.5 will be the output, and 1, which corresponds to the movement parameter values we set up in the animator. Hit play again and watch our player running. If the animation speed feels slow, go to the animator window and change the running animation clip speed to 2 for a faster running experience. To handle jumps, we first need to create a timer class which will keep our player controller code clean. Inside, remove inheritance from mono behavior because we want this to be an abstract class. Create properties for start time, current time, is the timer running, and the timer progress. Add events from when the timer starts and stops, along with a constructor and methods to start, stop, and update the timer. We want to inherit this class from two types of timers. The first is a countdown timer, which decreases its value in update, along with a few helper methods, and the second is a stopwatch timer, which starts at 0 and increases in update. From there, we can go back to the player controller, add properties for the jump force, jump duration, and the gravity multiplier, the ground distance, the ground layer mask, and whether the player is grounded or not. The jump velocity and jump timer will also be properties. In Awake, initialize the jump timer with a value of jump duration and register to the start method, setting the jump velocity to jump first as soon as the timer starts running. In on enable and on disable, we can register and unregister to the jump action of the input controller using a jump method similar to the run command. In update, to check if the player is grounded in the current frame, create a ray from the current position along the down direction and fire a spear along the ray using physics.spearcast. If the spear hits the ground layer within our distance property, then the player is grounded. We also need to update the jump timer here. In fixed update, we want to update the jump state of the player along with movement. In the jump method, start the timer only if the jump input button is pressed, the timer isn't already running, and only if the player is grounded. And stop the timer early if the button is released to create jumps of variable heights. Inside update jump, we stop the timer and reset the jump velocity if we have fallen back to the ground and the timer has finished running, and bail out early. To make the player fall faster once the timer has finished but we're still in the air, we update the rigid body gravity with the gravity multiplier. And to actually make the player jump, set the Y component of the rigid body to the jump velocity property. In the editor, create a new ground layer and set the world game object to it along with all its children. Assign the layer in the player controller component and hit play. Our player has now gained the ability to walk in the air. We'll take a look at how to add jump animations in the next video, where we'll create an even more sophisticated character controller.